Our topic for today is, as you see it here, ABAP objects, and I'll say more about the handout that I gave you as we go through this. We have, as we have proceeded over the last few weeks together, said that we would heavily leverage things that I am sure that you are familiar with based on your experience with other programming languages and other courses that you have taken prior to this one. And this area that we are about to move into is a good example of that. We're going to talk about how inheritance works in the ABAP programming language. So we will do some review of concepts, and I am very happy to answer questions, but I am anticipating that a lot of this will be very familiar to you. The idea behind inheritance is, as opposed to designing a single class that stands alone and provides a body of functionality along with data storage to us, we can think in terms of creating a family of classes that would be related to one another. And the idea is that it would allow us, therefore, to practice something that we really try to do a lot of in computing, which is code reuse, or reusing known good components in the creation of new things. And generally, the way this will play out in the design process is we start with the idea of creating a parent class. And a parent class is a general representation of something that will ultimately turn into a whole family of things that are related. And so the parent class represents the family at the most general level of abstraction, and therefore defines attributes and methods that would be common to everything that's a part of the family. So having said that, let's turn our attention to the handout that you have in front of you, which also is the ABAP code here that I have loaded up in the editor. And let's just tour this and talk about it for a moment. Certainly one of the things that we see a lot of in an ERP system is documents. There are, in fact, a wide variety of documents, and documents contain a wide variety of different business data. We can have financial documents, we can have material documents, we can have all kinds of different kinds of documents. But I would represent to you that every document, universally, at least in this example, every document has a document number, every document has a date, and every document has a type of document. So you will notice that I have defined a class called document, and it has three attributes: doc number, which is a numeric string of length 6, date, which is of type D, which makes sense for date, and then doc type, which is simply a one-letter code. So this could be A, B, C, whatever have you, and the idea here is that there would be some kind of organizational scheme to define this, but for the sake of our example, we're just representing it as a single letter. You will also notice that there is another class attribute, class data here, for num documents that just allows us to keep track of how many documents have been created, and you'll see where I use that a little bit later on in one aspect of the design of this class. So the idea here is, if we were going to create a hierarchy, we would start with creating the most general kind of thing. So in this case, we're going to create perhaps a hierarchy of documents. And so we ask ourselves, what things do all documents universally have in common? And the answer I came up with is the three things that you see listed here. Then as we move into methods, it really just becomes a case of figuring out what functionality is needed to support the attributes and the functionality of a document. And so you'll see that I've defined a constructor, which has three different parameters associated with it. Notice the document number is optional, and you'll see why I did that and how that is factored into the implementation here a little bit later. We have a date, which has the default value of whatever the current date is. And then we have a document type, which has the default document type of A. We also have 3 other methods. This would not be an exhaustive list of methods. Notice I don't really need any getters because all of my attributes are in fact public but designated as read-only. And by the way, I did just notice here that my document number is not designated as read-only. And so I am going to fix that in the editor and would encourage you to do that on your hard copy. That is strictly an oversight. So we have 3 public but read-only attributes. We have 1 public read-only class attribute. And then we have methods for constructing a document, setting the document number in case I need to come back after the fact, bless you, and change the document number, set the date, so if I need to come back after the fact and essentially change the date, and then I have a display doc method, which simply will write to the screen some kind of representation of the content of this document. So let's look at the implementation. The constructor increments the number of documents, maintaining that static attribute, pretty straightforward there. And then I tried to figure out a way to assign a document a default number unless the user wants to manually put in a number. Now, in reality, the way we would likely do this is we would have some kind of organizational scheme for sequentially numbering documents, and we probably would do some kind of database query here to figure out what the next open and available document number is, and then make the assignment. But I didn't want to, for the sake of this example, to do anything that sophisticated. We don't really need it. But I did want to create a way for there to be a default document number assigned. So what I decided to do is if the user did not give us a document number, so if the document number parameter was initial, then I'm simply going to assign the document number to be the current number of documents, which would mean that the first document created would get document number 1, the next one would get document number 2, and so on. Now, I did want to acknowledge this is not a good solution, so I put that in as a comment here. This is, in fact, a pretty poor solution. What makes this potentially a very bad solution? The answer to that lies in the domain of the fact that I also have this else clause here, which, what's the purpose of the else clause? What does that code do? Okay, so couple that with the question that I just asked, is my assignment of a default document number not a good solution? I wouldn't so much override it, but I could have multiple documents with the same number because, you know, I could have a document number assigned the number 5 because it was the 5th document created, and then I could manually create a document with the number 5. I could create multiple documents with the number 5 if I were so inclined. So if we want our document numbers to be unique, this is a particularly poor implementation. But for the sake of illustrating inheritance and to avoid having to write a larger quantity of code, this works fine in this situation. So my constructor increments the number of documents counter. It takes care of the document number assignment and then sets the date and document type based on the parameters, which means it's either going to use the default value or what the user has set it to. My set doc number method, pretty straightforward, just allows the user to change the document number. Same with set date. And then you'll notice display document does not do anything fancy. It just prints out document number, document date, document type, and then prints next to that the particular values of that. So you'll notice my start of selection statement, I create a document object named myDoc, and don't give it any parameters. So in fact, I'm getting the default values here, and then on line 58 I call the display method, and so this is the current output of my program. You see 000001, today's date of 3/30/2017, and document type of A. So this is the class that I have created, and for the sake of our overall discussion, this is a class which represents a parent class, which then can ultimately have children associated with it. And a child class is simply a more specific instance of the parent with additional methods and or attributes defined. So the idea here is, whereas the parent in this case might define a generic document, it could have a child that would define a accounting document, or it could have a child that could be a purchasing document. And so what we see here is everything that the parent has already defined, the children have. But we have the ability to add to the attributes or add to the functionality of the children to give them new things that have not been defined or created in the context of the parent. So we often think of this as an is-a relationship. In other words, an accounting document is a document, and a purchasing document is a document. We could even further extend this to say that we have documents, purchasing documents, and then we have purchase orders and purchase requisitions. And so the idea here might be a purchase order is a type of purchasing document. A purchasing document is a type of document. So we can just continue working our way up the hierarchy here, where every item, every child is a more specific example of something defined by the parent. And although I've only illustrated this here on the slide and on the whiteboard as a parent with two children, in fact, a parent could have one child, a parent could have as many children as they want, and just because one of the siblings, as in this example on the whiteboard, has children, doesn't necessarily mean that the other siblings need to. So I can construct a very unbalanced tree based on whatever my particular demands are. And the terms that we will often use, I'll often use, is talking about a parent class and a child class. But more formally, in computational terminology, we refer to the parent class as the superclass, and the child class is the subclass. And this terminology is consistent as we move up here. In this case, from what I've put on the whiteboard, we would say that a purchase order is a child of a purchasing document, and a purchasing document is a child of the document. So it's that kind of relationship as we traverse the entire tree. Any questions about any of the things that we have talked about? So on this particular slide right here, I've introduced UML notation, which you perhaps have seen before, nothing that hard to understand here, where you have a rectangle divided into three regions. The top region is simply the name of the class, the second region is the attributes, and the third region is the methods. And so you can see, much like the example I have given you by way of hard copy, document has three attributes: document number, date, and type, and then a set of methods. Well, then you'll see the left child is a PO document. And so the idea here, just to make sure we're clear, is a PO document has how many attributes does a PO document have based on this diagram? 6, because it has a document number, a date, and a document type, but then it also has a vendor ID, a company code, and a delivery date. And similarly, a sales document has 6 attributes: customer ID, company code, fulfill by date, and document number and date and document type. So as we move down the tree, every child has what is above it in the tree, working all the way back to the root node, it has all of those attributes and it has all of those methods. And it gets what it gets from its parents totally for free. And it just adds to it the new things that it needs. So this is the conceptual aspect of the idea of inheritance. Let me give you some few additional principles, and then we'll look at the code. The idea here, as I have mentioned, is we take those things that are most in common and we put those in the parent of the superclass. So as we think about this, we would put everything in the document class that universally defines and is a part of all documents. And then we move down the tree to a purchasing document, and we say, okay, what is universal to all purchasing documents that we need to incorporate? And the idea here is if it's a purchasing document, it has all of these attributes. And then we move down the tree and say, okay, what things are on a purchase order that then add to this further? So we're progressively adding more and more detail and definition. Items defined in the superclass are inherited in the subclass and are considered to be part of their definition. What this does is this avoids redundancy and allows us to engage in what is commonly called programming by difference, which means that the subclass gets all the benefit of the code that has already been written and then can just turn its attention to adding those things that are needed to be added that are new and unique to that particular class. There are some, although very few, programming languages that support what is called multiple inheritance. ABAP supports only singular inheritance, so a subclass can only have one parent. So a parent class can have as many children as are needed, but a given class only has one parent. So let me just ask you this question. In comparing the superclass and the subclass, which is the more specific class? The subclass. And as we work our way further down the tree, we're getting more and more specific with every generation. All right, so there's the concept. Let's look at the coding associated with this. So we want to create a child class. So in the child class, we add the clause inheriting from and then the name of the parent class to the first line of the class definition. So for the sake of our example here, let's do this. Let's create a, what did I put on the board here? A purchasing document or an accounting document? Yes, sir.
Can a child class manipulate the superclass, the main superclass directly, or does it have to go through the parent class?
We will talk about that. It can, but there are some particular rules that we have to follow. Okay? So let's do this. Let's create a, looks like later on in the slides I use example of a purchasing document. So let's create in our code here a purchasing document. So I'm going to come down here, and before my start of selection, I am going to now create this. And in fact, so what I'll do here is I'll say class purchasing document definition. And then normally we'd put a period there, but we're not going to. Inheriting from document. And there will be an end class statement, of course. And then as we know, my class purchasing document is also going to have an implementation. So I will go ahead and type that in as well. Notice that the implementation clause here, or the implementation portion of the class, doesn't have the inheriting from portion. We just put that in association with the child, or excuse me, with the definition. So notice this. In fact, at this point, we could do this. I could say data mydoc type ref2 purchasing document and create the object and then display the object, and we should in fact see that we get the exact same output here. because I have now defined a child, but there's nothing new added. So this is a situation where the child is exactly like the parent, which would argue that clearly we don't need the child unless we're going to actually add new functionality here. So we're going to do that, but let's take this one step at a time. The inheriting class, and this gets to at least a portion of the answer to the question I was just asked a moment ago. The inheriting class gets what they get from inheritance, and they can't delete it, okay? If we said that every document has a date and a document number and a document type, then anything that's a child of a document has those three things in it as well. But what about the methods? I cannot delete a method. The methods are the same as they exist in the parent, but if I want to, I can redefine the method implementation. So we're going to look at that. But first of all, let's take on the issue of the the attributes. We said that our main document here has attributes for document number, date, and document type. So let's figure out what attributes we would need to add to our purchasing document. So just as we always do, I'm going to create a public section, and then we'll have a data statement. And let's see here, what did I put in my notes here as something that would make sense as a unique attribute of a purchasing document. A purchasing document would have a vendor ID, and it would have a company code, and it would have a delivery date, okay? Now, we're not digging into the design here too much. We're just keeping this very general, but you get the idea that a purchasing document's going to add three new attributes, that being what vendor we're buying from, what company we are that's doing the buying, and when this item's supposed to be delivered. So now at this point, this just becomes a matter of assigning data types and other things of that sort. So we will make the vendor ID similar in structure to things that we have already created. And so we'll say that a vendor ID would be a numeric string, and actually a vendor number is a general string. So we'll do type C, length, you can't spell length, length 2, and we will make this read-only, as is our custom. And then company code type, we'll just do the same thing here, type C, length 2, read-only. And then delivery date, type D, read only. So we have added now three new attributes. So just to be clear, we now have a total of 6 attributes. And so this immediately calls to our attention that there's going to be 2 things that we have to actually change. What are the 2 things that we know we're going to have to change in terms of the functionality of the child? And we don't have a lot of choices. You can look at the functionality of the child. What needs to be changed here? Well, does the purchasing document have a document type? Every document has a document type, so yes. Okay. But what of our functionality here now needs to be adjusted? there's no problem with me. No.
You're going to display a different document for the purchasing document, so that's going to change a little bit.
Absolutely.
And you might want to change the date as well for how it gets set.
Well, the display document method, which I have inherited, is no longer sufficient now. As exampled by the code that I have here, where I created a purchasing document, and now I run this, and this is purporting to show me all the data in the purchasing document. Does that show me all the data in the purchasing document? Does not. So I am going to have to change the display document method. Okay? So, yes, sir.
Can you overwrite that in the purchasing document? Sorry.
Absolutely. That's what we're going to have to do. We're going to have to change the display document method. Set date method, does that need to be changed? No, right? I mean, you set a date for a purchasing document, you set a date for a document, everything's good there. What about set doc number? Does that need to be changed? No. What about the constructor? Does it need to be changed?
Possibly.
Why do you say possibly?
If you need these new values to be set, then you have to update your constructor to accept these.
Pretty much what we have seen universally is we have been using constructors to set up all the attributes. Well, I've just added 3 new attributes, so I need a new constructor to be able to take care of those new attributes. So the point here is, as I start looking at the child, I have to ask myself 2 questions. What new methods do I need to create? So for example, I might want to create a set vendor ID method or a set delivery date method. That would look very similar to the methods that are above this in the parent that work as setters. So I ask myself, what new methods do I need to add? And then I ask myself, what methods are a part of the parent that I need to change? Now understand, I can't delete any of the methods, but what I can do is I can redefine them. So I look back at the methods that are a part of the parent, and I ask myself, and really you just go method by method and say, does this method need to change? Or is it fine? And what we just determined was that my constructor method needs to change because it's no longer sufficient, and my display doc method needs to change because it is now no longer sufficient for a purchasing document. So how do I handle that? If I need to redefine something, what's the mechanism for that? Well, the first thing you have to understand is that when you redefine a method's implementation, the parameter passing cannot change, and the visibility cannot change. So what I'm saying to you is that as we look at our example code here, the display doc method, right now, the display doc method is, as we see here in the definition, it is public and it has no parameters associated with it. So I can define a display doc method for the child, but it also has to be public and it also has to have no parameters associated with it. Now, I don't need to do this, but let's say, for example, I said I need a new set document number method. Well, if I were going to do that, the new set doc number method could have totally different functionality, but it could only have one parameter of type importing. That's a document number of data type N. So what I do is I look at the existing methods and I ask myself, do any of these need to be redefined? And in this case, we have come to the conclusion that the display doc method needs to be redefined. So how do I do that? The answer to that is, in the child class's definition, I insert a statement that I'm going to redefine a method that has already been created and that I have through inheritance. Now, since the interface is already defined in the parent, I don't list the interface again. So literally, I just put this in the definition. Methods, the name of the method, and then the keyword redefinition. So if we go back to my example here, if I want to redefine the display doc method, I come down here and I say methods, display doc, actually there's an underscore in there, display doc redefinition. So let's be clear, I don't list there are no parameters in this one. But even if there were parameters, I don't list them. Because all this says is, hey, look at the parent, find the display doc method. Those are the same parameters that I take in, but I'm going to write a new definition for this guy. Yes, sir?
So this is just like method overriding in Java. So you have toString in the parent class and then the child class, but you use redefinition.
You got it.
Okay.
That's exactly what's going on here. So I look at any method that I want to redefine and identify it as such. And now I go down and I write the body of this in the implementation. So I see method, display, doc, okay, and then end method. All right, so between those starting and ending points, I need to put my code in here. And we'll talk about that in just a second. But you see what we did here. We looked at any method that if I want to create a new method, I could create any new method I want. But if I want to change an existing method that I got through inheritance, I list the method in the definition with the keyword redefinition, and the parameter passing has to be exactly the same as what I inherited, and then I go down and in the implementation, I write the new guts of the method. Now, if you think about this, I actually have a couple of choices here. What I could do is I could say, okay, look, here's this code right here. I could copy and I could paste it here, and then I could add more lines of code to it. I could add additional parts to the chained write statement. And as a point of fact, that would work. But that is very, very poor programming, because now what happens if I go back and change this up here? I don't want to have to go look and see what children have overridden that and make the changes multiple places as well. I want to be able to change it in one place and have that be universal. So if you think about it, what I want to do here is when this method gets called, I want to run this display doc method and then add new stuff to it. So how do I do that? And the way we do this in ABAP is very similar to other programming languages. If I want to call the method of a parent, such as when you want to call the original method as part of the method's redefinition, I use the notation super. So I could do this: display document super display doc. And so this is going to result in the parent class being called, the display doc method of that, which is going to write out the document number, the date, and the type. And then what I need to add on to that is code to display the vendor ID, the company code, and the delivery date. So this will be pretty straightforward. After I have my write statement, after I have the call to the parent, then I can come down here and say, okay, write out the vendor ID and the company code and the delivery date. And the variables here are now going to be vendor ID, company code, and delivery date. Now, we'll run this, and then we'll talk a little bit more about it. Here's what I see now. When I print out, because remember I changed my code already to say I wanted a purchasing document, and so I see the 3 attributes defined by my constructor for the parent, but this also now calls into point the fact that my constructor for the child doesn't do anything with setting the vendor ID, the company code, or the delivery date. So I'm going to have to fix my constructor. But notice the way the control flow worked here with the constructor. We use the parent constructor because we didn't redefine it. So anytime I use the child class and call a method that is part of the parent, it just uses that code. So I don't have to redefine everything. I only have to redefine the things that I want to change. Now in this case, I used display doc and called it in the way I did because it had no parameter passing. This next point I'll just show you as an example. This is a little bit goofy, but just to illustrate this, let's say I also wanted to override, let's pick another method here. I keep moving where I'm putting my code listing. We have a method called set doc number, okay? Let's change that one too. So I'm going to do this, methods, set doc number redefinition, okay? So I've alerted the system that now the purchasing document will have its own new set document number. So now I come down here and I will do method set doc number and then end method. All right, so there's absolutely nothing at all wrong with the parent class's set doc number method. But I just wanted to illustrate this. Suppose I want for the child for it to set the document number and then print out on the screen the new document number is as follows. Okay? So I would want to employ super just like I did with the display document method. I would say super, so call my parents set doc number method. But if you look at this, the set doc number method has to take in a document number. That's required. Well, when I call set doc number, I have to pass it a document number using the parameter doc number. So in fact, what I'm going to do here is when I call the parent, I'm just going to pass along that particular parameter. So let's make sure we follow this. The set doc number method defines a doc number coming in by way of a parameter. So I'm going to take that parameter that I'm passed and just turn around and pass it to my parent method. And then, like we said, then what we'll do here is we'll just write to the screen, write a new doc number of, or new doc number was assigned me, doc number. Questions about this? All right, so let's play computer on this. Let's do this. Display my doc, and then I'm going to do this. I'm going to do my doc set doc number, and I'm going to set it to be 1, 2, 3, 4, 5. And then I'm going to ask it to display the document to me again. So here's what's going to happen. On line 82, the set doc number method will be called, and I'm going to pass it 1, 2, 3, 4, 5. So that results in us jumping up here to line 71. And the first thing that happens on line 72 is I call the parent's set doc number method, and I pass it the number 1, 2, 3, 4, 5. That's what's going on right here. Well, that then results in me jumping up here to the parent, where it does the assignment, and then I return back to line 73, where I now print out my new parameter value of doc number, which we'll expect to be 1, 2, 3, 4, 5. And then now we jump back down to line 83, where we display the document again. So the end result of that is this right here. And you now, of course, see where I didn't put a return, so a new doc number is tacked on to the end of the former delivery date line there, but you do see a new document number being assigned, and then you see that when we print out the document again, that the document number, in fact, has been changed. So I can use super to call the functionality of a method that is a part of the parent class. Questions about that? Constructors, yes.
Maybe, well, actually, you're about to touch on it. I was going to say, can you call constructor super?
Yep, let's look at that. Constructors have special rules, and the rules for constructors are this. A subclass may use the superclass constructor as it is, which is what's going on now in our program, or the subclass may create a new constructor, and the most important part of this sentence is these last 4 words here, with a new interface. So all of the other times we've redefined a method, we've said the interface has to stay the same. But that's not the case with constructors. And if you think about it, we've been writing constructors that take in values for all the parameters, or for all the attributes. Well, if I want to do that for my purchasing document, and I'm stuck with having to reuse the old interface, how do I add in the ability to set a value for a company code or a vendor ID? I can't. So with constructors, we can just write a whole new constructor. The subclass constructor does not use the word redefinition. So we write this just like we do if we're writing a brand new constructor. So I would do this. I would go back to my code and I would say, hey, I need a constructor for my purchasing document here. So I would perhaps employ some cutting and copying and pasting, but let's assume not. I could do method. Actually, I need to go up here to the definition part first. And I would say methods, constructor, and then just like I did up here on lines 17, 18, 19, and 20, I would list my parameters that I want to pass in, and I'm going to copy this to save myself some typing. So my constructor method has importing parameters for document number, date, document type, but now I want to take care of my other attributes as well. So I'm going to add to this list vendor ID type C, company code type C, and delivery date type C, or delivery date type D. And now I get into, okay, what do I want? Do I have default values here? And so we'll do that. We'll say that the default vendor ID would be AA, and we'll make the default company code CC. These are probably not good default values, but just to illustrate this. And we'll make the delivery date. Now here's interesting. What I can't do, you might say, well, let's make the delivery date. Wouldn't make sense for the delivery date to be today's date. Can I make the delivery date 7 days from now? Could I make the default value to SY datum plus 7? And you'll see I can't do that. I can't do a calculation there. So that's why for this one, I think what we're going to have to do is just make this guy to be optional, and then we'll take care of setting a default delivery date in the method of it. So what I've done here is I've said, okay, my purchasing document needs a new constructor because my parent constructor wasn't complete. It did not give me the ability to set vendor ID and all these other things. So I write a new constructor. Notice this looks like I'm creating it from scratch. No word redefinition. And then I would come down here and I would do method constructor end method, and I would now write the guts of my constructor method. But if you're thinking about what we've done here, you might be thinking, well, you know, I don't want to have to rewrite all of the constructor code. The old constructor did a really good job handling doc number, date, and doc type. So could I just call the parent constructor and have it manage those three things, and then I just add the code for the new things? And the answer to that is I absolutely can do that. If you want to call the parent constructor, you do it like this. Super arrowhead constructor, and now you're going to have to put in your parameters. Note this, the calling of the constructor must be the first thing you do in the subclass constructor. So the very first line here has to be a call to my parent constructor. And my parent constructor is expecting me to pass in a doc number, a date, and a doc type. So this code's going to look a little bit goofy, but here's what I do. Doc number equals doc number, date equals date, doc type equals doc type. I'm going to have to fix my spacing here. So this is just like any other method call. I'm calling my parent's constructor, and I'm feeding it those three pieces of information. Let's save this and do a syntax check to make sure we're okay, and we are. And now I need to write my code for vendor ID, company code, and delivery date, and this is like what we've written before. Me, vendor ID equals vendor ID. Me, company code equals company code. And then lastly, now this is where I have to handle the fact that I want the delivery date. If the user didn't give me a default value, I need to calculate one here. So I do this. If delivery date is initial, which means the user didn't set it, then in that case I want me delivery date to be equal to the current date plus, we'll just say 7 days in the future. Otherwise, me delivery date equals delivery date. So I now have a new constructor. My new constructor leverages the old constructor to save me from having to rewrite code, but then takes care of the new attributes that I have added. This is an extremely common design pattern. The idea that I reuse what I can, particularly leveraging the parent constructor. And so now, let's make sure I haven't made any typos here. See how we do with a syntax check. We're fine there. And now when I run this, let me fix the a new doc number was assigned here. Let's put that on a new line. And so there we have the creation of the document initially. And you'll notice now I do have default values that have been put in. Vendor ID AA, company code CC, and in fact the delivery date is 7 days in the future. And then you'll see where I changed the document number and then printed it out again. So everything works exactly like I would expect it to. So if we continued in this fashion, we might have a child of the purchasing document class, in which case nothing would change here. We would continue in this fashion. We would override whatever methods we decided needed to be redefined. We would almost invariably have to create a new constructor, and our new constructor would make a call to super, which would in fact result in the child class constructor calling the purchasing document constructor, which calls the document constructor. And we just kind of work our way up the overall hierarchy here. Notice once again what we did here with set document number. We overrode it so that we could add new functionality just for the sake of demonstration. Line 80 is really a waste of code. But we called the parent, and in both lines 79 and 83, we have parameter passing as is needed to fulfill the interface requirements of those methods. Questions about any of this?
Yeah, so there's going to be times that somebody's going to want to just see documents, and then somebody's going to want to see drill down to a purchasing document. So just after you start a selection, just make your type reference to the different classes.
Yeah, let's
and then make one to the child and be able to manipulate.
Yeah, let's do this. Let's create my doc, which will be a type reference to just a plain old document, and then we'll display it, okay? And then we'll, just so we can divide this up, now we'll write out a message here. Now purchasing document, and I'll do this. Data my doc 2, type reference to purchasing document, create object my doc 2, my doc 2 display doc. So what's actually happening here is I'm creating both a regular document and a purchasing document, and I'm just calling the display doc method. I'm not putting in any default values here. I'm using I'm not putting in any values, so I'm using the default constructor. And so we see that when the user prints out the document, they just see document number, document date, document type. But when they print out the purchasing document, they get those 3 things and the 3 new things. And we have done this with minimal redundancy of code. This is how you do inheritance in ABAP. So let me just add a few more facts to this and see if there are any questions here. So really what we've observed here is the constructor method is the only method in ABAP objects which is truly overloaded. Meaning we have 2 methods that actually share the same name, which are defined separately. Because notice we didn't use the word redefinition with the constructor. So both constructors are in effect. For the child class, if I use the word I could do this. This would be really, really bad code. But for the child class, I could take the set document number method and I could change it. It could just write out on the screen, have a good day, which would be bad because that doesn't seem consistent with the set doc number name for the method. But the fact is, this set doc number method is totally independent of the parent. It basically is overriding the parent. Now, what it is doing is it's leveraging the parent by using the keyword super. But down here, if I were to make a call to set doc number, I would be using the one for the appropriate class. There's one other thing we haven't talked about, and it has to do with visibility. You'll notice that in my program, I use public read-only attributes. And as a point of fact, I've encouraged you a lot this semester to do that because it's available to us in ABAP, and there is no good reason not to do that. But suppose I had private things in the parent, either a private attribute or a private method. How does that work out in inheritance? Well, here's the way it works out. The child gets those things, but the child cannot reference those things directly. So let me explain what I'm talking about here by way of picture. We have an attribute in my doc class here called date, and we've made that public. So that means that down here in the purchasing class, it also knows that there's an attribute called date, and I could write a method in my purchasing document called doStuff, and in the doStuff method, I could just use that date attribute. I could write out to the screen, me, arrowhead date. I could do whatever I wanted to with date because I can see it because I got it through inheritance. Well, if that attribute were private, I wouldn't be able to see it. And in fact, if it were private up here, then probably I would have a method called something like getDate. And down here, I could call the getDate method to get at that. But if I made something private, I'm going to have accessor and mutator methods that are public, and then the child is going to have to use the accessor and mutator methods. It gets kind of hairy, and it gets a little bit confusing. So I have two different ways to solve this. If I do what we've been doing, which is making things public and read-only, I don't have to worry about this at all. But suppose I wanted to do something like this. I said, I want this to be private to the rest of the world, but I want it to be public to my children. Well, that idea is what we get when we use the word protected. So we have, to this point, talked about a public section and a private section. We could introduce a new section called protected section. And the rules of protected are just really straightforward. If for me and for my children, we treat this like public. But for everybody else, this is considered private. Protected, the reason why we haven't talked about it to this point is because protected is only relevant in an inheritance situation. Protected resources are defined in the protected section of a class definition, and protected resources are visible within the class and its children. And as I was saying, this is very similar to saying something is public to a class and its children, but private to everyone else. So this now gives us a new rule of thumb here. As you have been writing your class definitions, you've put the public section, and then if you've had one, you've put the private section. Now we see the actual order here is public section, then protected section, then private section. And we can omit any of those that we don't need. But I will say that the very nice thing about what we see in ABAP is that being able to make attributes public and read-only, it's not very often we actually have to resort to these things, or at least not as common as we would in Java or other programming languages. Questions about this? Yes, ma'am.
So why would you make it public and read-only over just making it private?
Well, I don't have to write accessor methods. I don't have to write a get document, get whatever. And so it saves me from having to do that. I mean, the question would be, why would you make something private? And typically the reason why you make something private is to protect it, and read-only protects it. So it's just it's kind of like saying in our home we could install an alarm system or we could buy a dog. And same thing here. You could use public read-only or you could use private. And the benefit of public read-only is I don't have to worry about all this other stuff. So it's kind of like the benefit of buying an alarm is I don't have to buy dog food for the rest of my life. So it's a trade-off there. I might like the dog, but there's advantages and disadvantages to either of those two options. okay?
But you have been able to do that like on whenever you have a structure, like we did with the homework, where we had to make it private. How would you do that with that?
You can make it
structure?
public.
You can-
Yeah, keep in mind that the type of the structure would probably be public because the type just tells you what fields are and stuff like that. But then you would have a data statement that actually creates the object, and that data statement, you just move it to the public section. So you'd have in the public section, data, my struct, type, struct type, read only. And that would work just great.
Thank you.
Other questions?
Would you always have to think ahead and put the protected section in the superclass, or in this scenario, could you put a protected section in the purchase and then it only be accessed by purchase order and purchase record?
Yep, you can add stuff. Exactly that. You know, and I certainly would think that in a lot of real world situations, you might wind up in retrospect going back and editing this to set it up for inheritance. But you can absolutely, you know, this could be all public, this could be public and private, and then this could be public, private, and protected, you know, whatever you actually need there. You can always introduce that. Now, there's one thing we haven't talked about to this point, and that's what about static elements, class data and class methods. And remember, the whole idea behind class methods and class data was that they're shared universally. And I don't have to actually instantiate an object to get them. So, how does this work? A class shares static attributes with its children in the same fashion as other attributes. A class shares static methods with its children, but once a static method has been defined, you're stuck with it. You cannot redefine a static method. Just one of those rules of thumb. And in fact, I think we have, do we have a static attribute in the code that we've been working with here? Our document, or the num documents is actually static. And we saw, in fact, that this worked, even though we didn't call our attention to it previously. Notice that my document number here is document 1 and document 2. That tells you that both the parent and child are working from the same document number counter, okay? And that's fine. We don't have any static methods, but the point is, if the parent had defined a static method, we couldn't override it. We're stuck with that forever, and that's just the rules of something, in fact, being static in ABAP. Inheritance in ABAP. So let's talk about your next homework assignment real quick.